All right, good morning. Welcome back. Hopefully you had a good day of reading yesterday. Today's not going to be too difficult, and we're not going to take too long doing this today. The discriminant is pretty easy, and I mean that's really all it is. If you know your quadratic equation, the discriminant is easy. So let's review. The quadratic equation is this, or the quadratic formula, sorry. Quadratic formula looks like x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. This here is the quadratic formula. The discriminant also has a formula, and the discriminant is going to equal b squared minus 4ac. And you'll note that is just the part underneath the radical of the quadratic formula. So this here will be the discriminant. And all what you're going to do is plug into this to get your discriminant, and then you have to learn how to read your discriminant and what the discriminant does. So what does it do? What does the discriminant do? Well, all what the discriminant does is it's going to tell you how many answers you get. Tells how many answers for x there are. Because if you recall in quadratics, your answers are wherever your parabola crosses your x-axis. Sometimes you can have two answers, sometimes you have no answers or no real answers, they'll be imaginary numbers, and sometimes you have one answer. So the discriminant is going to tell you how many answers you should be expecting. And it's just another tool to use to check your work as you're going to make sure things are making sense. And sometimes people ask questions about, hey, how many times might this cross the x-axis just by doing it? And that's the question you want. Then you don't have to do the whole thing and get your answers. You just have to take the discriminant of it. So what does the discriminant do? Basically, you'll note that it has this square root symbol. So whenever you have, if the discriminant is less than 0, or if it's negative. Right? So if the discriminant is negative, then you're going to be taking the square root of a negative number, which means it has no real solutions. If your discriminant is 0, then it's neither, then it's going to be the square root of 0. So, it's going to be the square root of 0. And that only equals 0. It doesn't have a plus or minus version of that. So in this case, there's only going to be one answer, or one solution. And if your discriminant is greater than 0, in that case it's going to be a positive number, then you're going to have two solutions. And that's really all there is to it. You look at your equation, you plug it into here to find your discriminant, which again is just whatever's under the radical in the quadratic formula. So if you have this memorized, you have this memorized already. It's the whatever's under the radical. Plug it in there. If your answer is negative, you have no real solutions. If your answer is 0, you have one solution. If your answer is positive, you have two solutions. So let's go ahead and do a question. It's really going to be that simple today. Hopefully this is not going to take long because I'm behind on grading. Let's see here. We don't need the quadratic formula for this either. So let's look at our problem. I'm just going to take them out of your homework. Save you some time there. So this is page 556. I think I assigned 1 through 15. We're going to look at number 4. Number 1, 2, and 3 you can answer with what I just told you, hopefully. Number 4 says x squared minus 3x plus 4 equals 0. It's asking for what the discriminant is. Find the number of solutions. No, it just wants to tell you how many solutions does this have. So, how many solutions are there? In other words, find the discriminant. So what we're going to do is we're just going to plug into this little formula, and we're going to get an answer. So remember, A, B, and C have values. This is equal to 0, so that's our first step. Make sure that's equal to 0 as always. And we're ready to do our quadratic formula. We can find our discriminant. A is the value in front of your x squared term. In this case, it's going to be 1. B is the value in front of your x term. In this case, it'll be negative 3. And C would be the 4, which is the constant. And then just plug it into here. So we get negative 3 squared. And remember that negative sign is attached to that 3. That's part of B. And you're squaring all of B. Minus 4 times 1, because A is 1, and times 4 because C is 4. In this case, you get negative 3 squared, which gives you a positive 9. And then you're going to subtract 4 times 1 times 1, which is it's a negative 4 there, so it's going to be a negative 16. And in this case, you're going to get a negative answer. I don't really care what the answer is. I just know it's going to be negative. And when we get negative discriminant answers, there are no real solutions. This one here is going to have no real solutions to it. And you can go ahead and finish off the quadratic equation, and you can see that your solutions are going to be taking the square root of a negative number because, well, you did the part under the radical and it turned out to be a negative number. So your answer is going to be an imaginary number overall, and therefore there's going to be no real solutions. It's really that simple. I don't know if there's any in there that actually like throw you a curveball or something. I guess we can do number 5 because it has at least some solutions to it. So again, here's number 5. We just plug into the discriminant. So we have x squared minus 6x plus 9. Your a value here is 1. Your b value here is negative 6. And your c value is 9. Plug into here, that becomes negative 6, and again we take the negative with it, squared minus 4 times 1 times 9. You get negative 6 squared is 36, minus 4 times 1 times 9 is 36, and that equals 0, so your discriminant is 0. In this case, that means we have one solution. Remember, if your discriminant is negative, you have no real solution. If it is positive, you have 2 solutions, and if it is 0, you have 1 solution. In this case, you have 1 solution. And I think number 6 has 2 solutions, so we'll see what that looks like. Number 6 is x squared plus 4x minus 2 equals 0. Again, it equals 0, so make sure it equals 0. If it doesn't, move it around. Here, a is still 1, b is 4, and c is negative 2. So you get 4 squared minus 4 times 1 times negative 2. 4 squared is going to give you 16. Negative 4 times 1 is negative 4. Negative 4 times 2 is positive 8. And this equals 24, which is positive, and therefore it has 2 solutions. Any questions on it? That's really all there is to it. And have at it. While you're thinking of questions, if you have any questions on science, this would be a great day to ask, because we have time to discuss forces if you want, but that's really all we're doing today in math is the discriminant. It tells you how many answers or how many solutions there are. Just plug into the formula and solve. For science, you can try your best to get it by Thursday. A lot of you have been asking for more time, and I'm willing to give you more time under the circumstances. I emailed you about that force packet. Again, it's mostly drawing pictures, and I don't really want to look through a bunch of photographs that I can barely see and try to make out what you were drawing, so I didn't really find a good way to do that. I mean, I asked you in the quizzes to draw an unbalanced force and a balanced force. And so if you have your object, here's your mass, you have a force of 10 newtons on this side, force of 10 newtons on this side, they cancel each other out. So this would be a balanced force. If you have your object and you have your force of 10 newtons on this side, and you have a force of 5 newtons on this side, and a force of 7 newtons on this side, these will combine because they're in the same direction. So this is the same thing as having a box with a force of 12 newtons on this side and a force of 10 newtons on this side, and therefore motion will happen in this direction because this is a stronger force. It will overcome that, and it is a net force in this case of 2 newtons because they cancel each other out. It's stuff like that, but I mean, you got to draw the picture for it. This would also be an unbalanced force. And we have a positive net force. This here has a net force as well, only it's 0. Because they will cancel each other out, they're going in opposite directions. Or you get something strange that's like 10 newtons, 10 newtons, it's going to go in this direction by like 5 newtons, because half of this is going to cancel out by the other half of this, and it's going to go like that. But that's a little much for what I asked you to do, especially over the internet. It's going to be a little difficult to get in. Make sure you know Newton's laws. They can be a bit confusing. Object at rest or at a constant velocity will remain at rest or a constant velocity unless an outside force acts on it. This is also the law of inertia. How do you spell inertia? I think it's a C. Inertia. I don't know how to spell inertia. Things like that. Newton's second law is force equals mass times acceleration. Newton's third law is if object A exerts a force on object B, then object B will exert a force on object A that is equal in strength or magnitude and opposite in direction. If you can read my chicken scratch there. Inertia. Thank you. I didn't do too bad. If you count that as an R, and there's an I in there. And this one, right, if I throw a ball, there's my baseball, it's going to continue going in the same direction unless a force acts on it because it's moving at a constant velocity. So it's going to want to continue going in this direction forever, and it will go in that direction forever unless an outside force acts on it. Your ball doesn't do that in the real world because outside forces act on it, right? You have gravity. You have the force of gravity acting on it. So the gravity is pulling it down and accelerating it towards the ground at 9.81 meters per second squared. And you also have the force of friction pushing it backwards. So you have a couple outside forces on that ball when you throw it. However, if you did not have any air, so you wouldn't have air resistance as friction, and you didn't have gravity acting on it, that ball would go in the same direction forever. Yeah, I can do that. X squared minus 1 equals 0. Your A term here is 1, your B term doesn't exist, it's a 0, and your C term is negative 1. Is that all you needed? You do not have any coefficient to just a plain X, so it is 0 here. In that case, it's probably easier to just solve for X, because all you're going to be doing is adding 1 to both sides. Right? Add 1 to this side, add 1 to that side, you get x squared equals 1, then you can take the square root of 1, and that'll be plus or minus 1, so you know you're going to have 2 solutions here. That might be the easier approach to that, is just solving it, but if you want to use the discriminant, we can. B squared is 0 minus 4 times 1. I'm sorry, what is it? Yeah, 1 times negative 1, which is going to make this 0 minus negative 4, which is the same thing as 0 plus 4, which equals 4, and therefore it is positive, and therefore you have 2 solutions. But yeah, it was probably because of the hidden B term that you might not have gotten that. Any other questions about anything? Science? I don't know if you actually had questions on science. I was probably just rambling. If you want me to continue doing that. I like talking forces. Right, this here's a formula. Right, if you have a mass that's 3 kilograms and you're pushing it with 10 newtons of force, how much does it accelerate? You can do that. Equals x squared plus 2x plus 9. Again, still equals 0, so you're good. A equals 1, B equals 2, C equals 9. It's B squared, 2 squared minus 4 times 1 times 9. 2 squared is 4 minus, this is going to be a big number. 4 times 9 gives you 36. I don't know, it's a negative answer, so it has no solutions. Any other questions? Again, I think it's pretty easy today. Tomorrow, not so much. Just to, I guess, recap in math, we had for quadratics, we had graphing it. So make sure you know how to graph things. We had square root stuff. Make sure you understand square roots. And then we had solving, which you could have done like one of 4 different ways, I think. Actually 5. We solved by graphing. We solved by square roots. We solved by factoring. We solved by completing the square. And we solved by the formula. And then today we did the discriminant. And tomorrow we're going to do modeling, which is going to be the rest of the week probably. So basically, if I give you a data set, if I give you an XY table, and I say X is 1, Y is 2, 2, 3, 4, 5, so, something like that, what is the equation for it? And is that equation, in this case it's linear, but linear, exponential, or quadratic? And it's going to be a pain. And then I'll tell you how to do it on the computer, and it'll be easy. So that's going to round out that chapter. And then our next chapter is going to be about square roots and radicals and reducing radicals. So when you come, what was it, Nora and I were doing some of this yesterday. When you get like the radical, I think we did 28, a square root of 28, that can be reduced down to the square root of 4 times 7. And you know the square root of 4 times 7, square root of 4 is 2. So you should be able to write that like that instead, which is nicer. That's the next chapter. It's not too difficult compared to quadratics. Quadratics are a pain. But you guys seem to be doing pretty well. And if you have questions, you seem to be asking. So keep up the good work. I'm going to let you finish. If you have any other questions, you can email me. And that goes with science as well. Again, if you're struggling to meet Thursday's due date for science, that's fine. Just be aware I'd like to get through at least one more chapter in science this year. But given all the circumstances, that kind of changes day to day, so we'll cross that bridge when we get there. But let's just focus on this chapter right now and getting the forces done. Again, if you have questions, email. I try to get back as soon as possible. And I will talk with you guys tomorrow. So long.